Inspection testing is one of the most important factors in assuring that the structural integrity of steel is not compromised in the event of a fire. Field inspection of spray-applied fire-resistive materials, or SFRMs, indicates whether the material meets the specification for thickness, density, and bond strength. These are in-place performance characteristics that directly relate to the ability of the SFRM to remain in place on the steel for the design life of the structure and perform in actual building fire conditions. This video is intended to instruct the viewer by demonstrating the proper methods of thickness, density, and bond strength tests, which are essential for the evaluation of in-place SFRMs. You will need the following items: a scale capable of weighing the test specimen to within 1/10 gram accuracy, a rectangular template having a minimum area of 48 square inches and being at least 3 inches in one dimension, a knife and scraper for cutting and removing the sample, a thickness gauge and tape measure, size number 8 lead shot or unexpanded polystyrene beads with a nominal diameter of 0.04 inches, a funnel having a diameter of approximately 6 inches and a bottom diameter of approximately 1 inch, a minimum 250 cc graduated cylinder, a deep-sided tray or pan, a minimum 400 milliliter beaker, a minimum 6-inch long rigid straight edge used as a screed, 2-component urethane adhesive, rubber gloves, a spring scale having a hook attachment and a capacity ranging from 26 to 66 pounds and an accuracy of 1/4 pound, jar caps that are between 2 inches and 3 1/4 inches in diameter with a depth of approximately 1/2 inch with hooks, a drying oven capable of maintaining 109 degrees Fahrenheit at no more than 60% relative humidity. When performing thickness testing, conduct measurements on a random basis in pre-selected areas in at least one bay per floor or for each 10,000 square feet of floor area, whichever provides the greatest number of tests. Testing should be done on one area of metal deck, one column, and one beam or joist or truss. When measuring thickness, the test area must be free of physical damage and have a surface texture relatively free of excessively high or low points. For beam thickness, the points at numbers 1 through 9 are measured. For columns, measure points numbered 1 through 12. Joists and trusses are measured at 7 points. For beams, columns, and joists, 2 sets of measurements are taken 12 inches apart. Measurements are taken by inserting the pin of the thickness gauge perpendicular to the substrate. When the pin touches the substrate, move the sliding disc to the material surface. On flat decks, measure 4 points symmetrically within a 12-inch square area. For fluted deck, mark the area and take 4 random symmetrical measurements on each of the following: valley, crest, and sides, for a total of 12 measurements. Individual measurements that exceed the specified thickness by more than 1/4 inch are recorded as the specified thickness plus 1/4 inch. Any area where an individual measurement is more than 1/4 inch or 25% less than the specified thickness, or where the average thickness is less than that required by the design, is considered a failed area and must be corrected by applying additional material. Each set of thickness measurements for the different structural members or deck section are then reported individually. Density testing is conducted at random on each of the following protected elements per floor or for every 10,000 square feet, whichever produces the greater number of tests: the flat portion of the deck, a beam, either the bottom or the lower beam flange or the beam web, and the column, either column web or the outside of one of the column flanges. Mark a 48 square inch minimum area, that is at least 3 inches on one side against the material surface, and score. Measure the thickness at 12 points within the area. Cut through to the material surface where the surface was scored. Without losing any material, carefully pry the test area from the substrate into a container and place in a plastic bag. Dry the material in an oven at a temperature of 109 degrees Fahrenheit and a relative humidity of no more than 60% until constant weight is obtained, when weighed at 8-hour intervals. Record the weight of the sample and calculate the density as follows. Density in pounds per cubic foot equals the weight of the dry material in grams multiplied by 3.81 divided by the length of the sample in inches multiplied by the width in inches multiplied by the average thickness of the sample in inches. Displacement method for density. Carefully remove a sample having a minimum size of 8 cubic inches by cutting to the substrate and prying the material from the steel. The sample shall be cut to a uniform size, removing all uneven edges. Cure the sample as previously explained in the calculated volume method section. Weigh the sample and record the weight. Place the empty 400 milliliter beaker in the center of the flat pan and pour the lead shot until the shot falls over the rim of the beaker. Screed off the excess shot and discard the overflow. Pour the shot remaining in the beaker into a holding container, leaving approximately 1/2 inch of shot in the beaker. Place the sample in the center of the beaker, making sure no edge touches the side of the glass. Pour the remainder of the shot from the holding container over the sample, allowing the excess shot to flow over the top of the beaker into the pan. Do not leave any shot in the holding container. Screen the excess shot and remove the beaker from the pan. Using the funnel, pour the shot collected in the pan into the empty graduated cylinder and read the volume displaced by the sample in cubic centimeters. If necessary, gently move the cylinder side to side to level the shot. Calculate the density using this formula. Density measured in pounds per cubic foot equals the dry weight in grams multiplied by 62.43 divided by the volume in cubic centimeters. When performing bond strength testing, conduct one test for beams and one test for decks for each 10,000 square feet of floor area with a minimum of 2 tests per floor. Hooks should be inserted into the caps prior to arrival at the job site. Prior to testing, the SFRM must be fully cured and dry. Normally, SFRM is dry and fully cured 21 to 28 days after application, depending upon thickness, temperature, humidity, and ventilation. Pour one of the 2 adhesive components into the bottom of the cap, pour an equal amount of the second component into the cap, and mix thoroughly. The urethane must be warm to work properly. A 12-inch square area shall be selected at the predetermined location. When this size test area is not available, the sample size shall be the width of the beam, column, or flute by 12 inches long. Minimum test area is 4 inches by 12 inches. As soon as the urethane begins to react, press the cap firmly against the surface of the SFRM in the center of the test area. Hold the cap in place until the adhesive has adequately cured. Wipe away excess adhesive before it cures or cut it away after it has cured, being careful not to disturb the SFRM. Position the scale into the screw eye or hook. Start to pull and slowly increase the amount of force supplied perpendicular to the surface at the rate of 11 pounds per minute, or 1 pound every 5 seconds, until failure occurs. Record the force registered on the scale at the time of failure. Calculate the bond strength using this formula. Cohesive adhesive force measured in pounds per square foot equals the recorded force in pounds divided by the area of the jar cap in square feet. It should be noted that the bond strength of some high-density fireproofing materials may exceed the capacity of this procedure for job site testing. In such cases, alternate test equipment may be employed. For additional information and clarification, contact Technical Service at Isolitech International, telephone 973-347-1200, or at our website at www.cafco.com.